And great. Hey, everyone. Today we're going to be talking about MLOps on AWS. We're going to be building the base of a MLOps platform on AWS. We're going to train a model on it. We're going to deploy that model and serve features to it. We'll be doing all of this using kind of the built-in AWS tooling. Obviously, you can deploy open source tools on AWS. But yeah, at any point in time in this presentation, feel free to ask questions. If you are in Zoom, you can throw in the Q&A. If you're on LinkedIn or Twitter, you can go ahead and leave a comment there. We will also afterwards be sending a recording of this if you need a recording, as well as sending anything that's relevant. You'll be added to an email list so that you can get updates on different webinars that are happening, as well as there will be a link to a Slack channel that you can join, or Slack community you can join if you have any questions or you want to be amongst other MLOps practitioners. Great. Without any further ado, let's jump in. So I have a few tabs open. We're going to go through all of them. I'm going to start by first just giving a presentation on MLOps, MLOps platforms, and SageMaker. And at the end, I will be talking about actually building features, training them all, and deploying them all. So we'll talk about the whole piece. So let's start with the simplest model. When we learned data science, at least when I learned machine learning, I was given this nice static data set, like a CSV, that had these perfect features in it. And all I had to do was train like a linear regression against it. I would have very basic hyperparameter tuning. I would just have like some loop, and I would train it against some labels, and that's it. You wouldn't really deploy the thing. You just make a few predictions offline. Now, in the real world, it's much, much messier. In the real world, we're working in notebooks with lots of different people. We're dealing with data that's everywhere and different types of infrastructure that's not cleaned up all the time. We're working off of other people's pipelines, building our own pipelines. We build lots of different features. Some get used, some don't. We end up with a ton of different models, a ton of different experiments that we run, and it's kind of chaos, which is kind of why MLOps came to exist. The goal of MLOps is to provide a tool set that makes it easier to iterate on, deploy, manage your model or your machine learning lifecycle from end to end. So the next thing I want to do is actually break down the components of an MLOps platform. So what are all the key pieces you need in MLOps? So there's two axes. One axis is the stage of the ML lifecycle. Again, MLOps should apply across the full ML lifecycle. And the other axis is level of abstraction. Now, you can build models and train models working at like on some servers. You could do in C if you wanted. Like you can work on a very low level if you want. So there's different layers that you can apply on that will add different value to the lifecycle. So let me start by explaining every piece of the lifecycle. There's data, experimentation, deployment, and monitoring. Most ML projects start with the data, getting your data in order, doing data analysis, and doing basic feature engineering. The second stage is actually training models. That's where you're going to be doing hyperparameter tuning. You're going to be trying a lot of different models, etc. Then we get into deployment and serving, where once a model is trained, we actually need to get it into production to be able to serve features. And then finally, monitoring and evaluation. The journey does not end when the model has been deployed. data changes, things happen. You want to make sure that you are monitoring and evaluating how it's doing in production. It's not just one way through. Oftentimes we'll be constantly iterating on models, we'll be jumping between the stages, but most of the time you can imagine that you're in one of these 4 stages, and the problems that you face and the tool sets that you need will be distinct. So to break down and build this MLOps platform breakdown, I'm going to put these 2 axes together. On the bottom, there will be those ML lifecycle stages I just spoke about. On the left, there will be the levels of abstraction from hardware up to platform. I'll fill them in with these components, and I'll start going through them. Well, first let me talk about a few of them. One is layer 0. Layer 0 is your hardware. That could be like AWS, could be VMs if you're on-prem. That's the compute, the lowest level of compute. Above that, we typically have some sort of framework. That could be Kubernetes, for example, could be nothing. Layer 2 and 3, that's the layers that I would call distinctly MLOps. And you can tell because they're segmented based on the different parts of the ML lifecycle. So there's the feature store, which is all about the data. There's the experiment trackers and training services, which is all about training and experimentation. There's orchestration and management of models, which is about deployment. And then finally, there's evaluation. There's 2 layers here, which I'll get into. And then the final piece, which is layer 4. Layer 4 is the holistic piece. It kind of makes all these components work together holistically. So for example, if you have a feature store, that is very specifically focused on the data parts of ML. It's not going to be as focused on evaluation or deploying models or all that stuff. Now, it needs to work seamlessly with those things, or you have to make them work with those things. And an MLOps platform or layer 4 can make all that much cleaner and easier. So for the sake of this presentation, I'm going to focus on layer 2 and 3, which I would call the main components of the MLOps platform. In the demo I'm going to give at the end, we're going to be using SageMaker for everything except for the feature store. We'll use Featureform on top of Redis and Spark. Redis and Spark will be running in EMR and in Elasticache. So all of this will be running on AWS. Featureform will be deployed on EKS. But yeah, we'll be using SageMaker tools for a lot of it. So the next thing I want to do is talk about the actual components of a feature store. I want to talk about the components that actually make up a feature. Because I think it's going to be a really important piece. I've found in practice that the hardest parts of ML, depending on the scope of what you're doing, is usually evaluation or data. So let's talk about the data piece first. What are the components of a feature? Well, from left to right, there's the data sources, the transformations, the inference store, and the training store. Every feature starts with a data source. That could be a CSV, it could be a table, it could be a stream. We will typically transform it. Like, it won't just be given to us perfectly and cleanly. There'll be a set of transformations. It doesn't have to be a single transformation. It actually rarely is just one transformation. It's usually many chained together that build the actual features. The features have to be stored in 2 places. One is the inference store. This is like a cache of the values of features. So if I have a model in production and I need to serve features to it, I would like to hit some cache so I don't have to process all of this user data every single time I need to make a recommendation. I also need the training store. So the training store stores the features values over time. So the inference store is a cache of the most recent values of the features. The training store, on the other hand, is specifically the historical values of features, which allows me to train. Because think about what training is, especially on time series data. You're going to want to know not just what the feature values are now, you're going to want to know what the feature values were at different points in time. Underneath all of this is infrastructure, right? Like the data source is stored somewhere, like S3 in this example, transformations are run somewhere, EMR in this example, the inference store is Redis, and then the training store will be S3 as well. Now, there are more components that come into features and feature stores, like governance, monitoring, and search and discovery. You may find also that there are different types of feature stores, and they have different interpretations on the problem and how to solve it. When people typically hear feature store, they imagine a database where features are stored. And that's true actually of a certain class of feature store, which like Feast has, SageMaker's feature store is kind of like this, so it's Databricks, where it will take data, transform it, and store it in a literal feature store. The thing here is if you think about the components of a feature, the data source and the transformations are no longer in the feature store. Rather, the output is like an artifact that you store in a feature store. This is distinct from Featureform's approach, which we'll see in a moment. In the Featureform approach, you define your transformations and your features as logic. So the feature is not a table. It's not just like an artifact that you output. The feature is the pipeline itself as a whole. Featureform then orchestrates that on top of your existing infrastructure. So in this example, we will be defining our features in PySpark and SQL in Python on a notebook. That will get sent to Featureform, where it will be stored as metadata. And then it will be orchestrated on top of AWS, Spark, and Redis. What that gives is a dashboard, a resource repository, tools for collaboration, monitoring, governance, orchestration, and more. The value of a feature store, why it's so important, is there are 5 components or 5 value props, key value props of a feature store. There's facilitating deployment, which is enhancing collaboration, organizing experimentation, increasing reliability, and preserving compliance. Facilitating deployment is the problem where I have my features. When I'm doing experimentation, right, I am working in a notebook. I might be working in like pandas or on some sample of data or something. But when I need some production, I need to start worrying about streaming data, perhaps. I need to worry about maybe triggered runs for batch. It doesn't just happen once. I need to worry about on-demand features or features that are processed at the time of the request. So I need to almost take my logic and put them into the right kind of thing for it to work for whatever type of data we have, whether it's a streaming transformation or something else. So Featureform specifically makes that very easy. You would define your transformation logic, and then we would kind of encapsulate it in a streaming transformation, for example. The problem that solves is if you've ever run into this, where you have this perfect feature, it's in your notebook, and you want to deploy in production, and that's a problem. It's hard. There's a huge amount of problems that can happen in production you don't have to think about in your notebook. Like I mentioned, there's streaming, batch, and on-demand. Like the streaming features. With streaming features, you end up in situations where, unlike with a batch feature or when you're experimenting, your data set is static. In streaming, you need to have a job that's constantly running, constantly updating, and keeping your inference store up to date. There's also on-demand features. So there's batch features as well, which we kind of all understand, so I kind of skip over it. But there's on-demand features. There's this concept where I have features where I need to featureize something at the time of the request. A good example of this would be if you want to view if a comment is spam. Well, you won't have the contents of that comment until request time. So you won't featureize the request until the time of the request. So yeah, those are the different types of features. There's a question that was asked about going back to that diagram, which I'll be happy to. The other pieces are enhancing collaboration, organizing experimentation. These are the concepts where you have these training sets or these feature pipelines, and you don't really have any documentation on it, I guess simply. This may look familiar to you or may not, depending on where you work. If you work at an enterprise company especially, this is going to be probably very close to home, where you'll have features in production, you'll have untitled notebooks, you'll have weird variable names and data frames and underscore v2 tables and Snowflake. You'll have ad hoc Spark submits, shell scripts, and then no feature documentation. This is super common, and it's a problem that Featureform aims to solve. Final piece is reliability. Features change, their values change over time, they tend to drift. And so you want to make sure that when a feature is actually in production, that you are actually keeping track of them. The final thing is preserving compliance, which is kind of obvious. Like you want to make sure that your features and your way your features are built are compliant, are properly governed. So a feature store should be able to make that much easier in the feature pipelines. Okay. I'm going to go back a bit, and I think I rushed through a little bit too quickly the first bit where we break down the platform. So I'm going to go back to that, and then I'm going to come back to this slide. So these are the dimensions of a MLOps platform. On the bottom, there's the stages of ML lifecycle: data, model, deployment, monitoring. On the left, we have the layers of abstraction. Layer 0 is hardware. In the end, everything is just CPUs and GPUs. Where are those CPUs and GPUs? Layer 1 is compute framework. You probably are not working at the instance level. I mean, maybe, but most people aren't like spinning up VMs to go work on. They'll be using something like Kubernetes or some other sort of framework, generalized compute framework above the hardware. Layer 0 and layer 1 are actually not really MLOps specific, right? Like if you use AWS, that's not really an MLOps specific thing. However, layer 2, 3, and 4, which are MLOps, are dependent on those layers. So for example, if you are on premise, you can't use SageMaker because doesn't fit. So the layer 0 and 1 is going to be what enables 2, 3, and 4. If your layer 0 and 1 don't, for example, like if you don't have GPUs, that is probably going to affect some of the things that you can do in the upper layers. So those are the bottom two, which I think are a little bit obvious. Now, let me spend a little more time on 2 and 3. So firstly, why is there layer 2 services and layer 3 workflow at all? Why don't we combine them? So layer 2, I like to think of it as the engine. It is the workers almost, like the things that actually store data, transform data, train the model. For example, in the data layer, the thing that stores the data, transforms the data, and those components would be layer 2. Layer 3, you can think of it as like the workflow layer. They're like the framework that you would use to orchestrate your Spark, Redis, S3. So that's Featureform as an example. Let me talk about layer 2. So obviously SageMaker kind of does a lot of things in their different services that they offer, but let me be a little more general. So for layer 2, for training, the problem to be solved is I have a model, or yeah, like a model definition. I have some data I want to point it at. I need a job that I can run that will train that model. So in AWS, for example, if I look at my training jobs, here's a training job I ran, which I'm actually going to run again. You can see the hyperparameters I used, right? You can see the output data. You can see the input data I use. You can see where the model is stored in the end. This is the training job. Now notice that this is different from something like MLflow, which I would say is above. So where we would have the training service, above the training service, we might have something like MLflow. And with MLflow over this, MLflow is less about training the model. It's more about keeping track of the different training runs, the different parameters you use, being able to compare and contrast, keeping track of which models and artifacts were created in each run. So the training service is the run, or it runs the thing. And the experiment tracker like MLflow would actually do the things, experiment tracking and model management above that. For deployment, the serving layer is about, it's like the actual container that runs the model. So it could be something like Seldon Core or Bento or Kserve. They have their containers, and those containers, you essentially put them all in it to run, but it's a single worker. Now, when you think about doing things like A/B testing, canary deployments, rolling rollbacks, and the like, then you need something above it, like an orchestrator. And so again, SageMaker has some stuff, but there's tools like open source tools like Seldon, which do this very well. On the monitoring and evaluation bit, the monitoring service, as you can imagine, it's a worker. So in this case, it would be the thing that collects the logs or samples the logs from the model, and then actually allows you to run queries against those logs. Now that's nice, but I would love to have some sort of UI and some framework above that, or some sort of dashboard above that, to get a much smarter picture of the data without me having to kind of manually write my own queries and try to figure it out myself. And so that's where evaluation tools like Aporia, YLabs, etc. come in. So those are the components. Now, above all this is the platform layer. So there are things there like Kubeflow, for example, that try to provide the generic abstraction on top of all these things, right? Like Kubeflow itself like works with Featureform and Kserve and all these different things and tries to make them work together cohesively. Metaflow is similar. Flight is another example. A lot of people also build their own here, where they will pick like a feature store, they will pick an experiment tracker, they'll pick a model deployment mechanism and model monitoring, and then they will build an abstraction above it all that is really specific to their company and use case. Awesome. Any other questions about this before I continue forward? I know I kind of, yeah, I saw a question, just jump in. Awesome. Yeah, if any other questions come up, please feel free to answer them. Next, I'm going to jump into, now that we have that, obviously it's very important kind of pre-understanding so that the next piece I do kind of makes sense. So let me talk about, or let me show you some code. So I have a few things deployed already. I have Featureform deployed. I have it just deployed internally. I have some data infrastructure deployed. So I have S3. I have a lot of the stuff, but a lot of it we're not using. The ones that matter are Spark on EMR. I have Redis, or this one, which I'm using for this example. And then I have S3. So all this stuff we use, I have run it for other webinars. And then I have in AWS, I have SageMaker running. I have one notebook instance running. And that's it, essentially. I just have the notebook instance running. In SageMaker, the way it works is everything works out of the notebook. So you would kind of use the notebook to accomplish all the things you need to accomplish. So you kind of define your training jobs, run them, deploy the models. All that happens from a notebook environment by default. Obviously, you can do it in different ways, but that's kind of the more traditional one. And then finally, or not finally, let's jump in, I guess. Cool. So I'm going to go through the example now of building a model, training it, and deploying it on SageMaker using Featureform. So I have Featureform installed, I have Featureform Enterprise installed. I connect to it. So I just give it the host. We have our own thing that we've deployed here. So if I needed to, in this case, I've already done it, but I can define my providers. Providers are, again, the underlying data infrastructure that Featureform will use to build your transform or run your transformations on your data. I can define, like I have this file in this sandbox S3 bucket, and I can define some of my sources already. So this is called transactions raw. You can see when I ran it, and I'll run a few of these things again, but you can see in this case when I ran it, it actually made a source and a transformation. They're both data sets, and they're both in ready state because I already ran them. And the other thing I can do is everything in Featureform, whether it's a table or a file or whatever, you can retrieve as a data frame, which is what I do here. If I go to Featureform and I go to my data sets, I can actually see transactions raw. I can see it's ready, and then I can preview it if I wanted to. So I could see the data in it. Cool. So yeah, you can see the data, you can see the columns, etc. And again, you can grab this as a data frame in S3 or in your notebook. So that's my data set. I also built a transformation on it called clean. So if I go to transactions, there's one variant called clean, which is my only named one. And you can see how it was defined. You can see the lineage of it. You can, again, preview it. You can see training sets, features, and labels that are built off of it. Cool. So typically, someone else, when you configured Featureform, would have deployed or configured those providers for you. And then all you would have to do is just call get Spark, get Redis. And you can also get any of these things as data frames without having to do anything. So you wouldn't have to like download a file off S3, parse it, you get pandas, do all that. You just call client.dataframe on this thing with this limit. The nice thing here is it allows you to think of how you would send a data set to a coworker or a peer. You'd have to probably zip that file or whatever. Maybe it's already in Parquet. You'd send it to them somehow. Maybe you'd point them at a link in S3. Maybe you'd literally send it to them over Slack if it's small enough. And then they would download it, get it set up, open it in their notebook. That would be the whole step. With Featureform, you just register it, and then you could just send them a link. In the link, they can see what it was, see how it was defined, preview it, see the status of it, and they can then just use that thing by name in their code. They can also build off of them. So for example, here, I built a transformation. And I ran it. I have this PyDoc here. This PyDoc actually gets pulled and is added as a description in the UI. When I run this, it's stored and saved in Featureform, and then Featureform will run it. And I'll run this one to give you an example. But first, actually, what I want to do is I also want to show you that everything is versioned. So in this case, I have a version. It's defined automatically as a timestamp. It's not named version. If I go into datasets and I look for percent balance, which is here, you can see this one, right? You can see how it's defined. You can see the description here. You can actually search if you wanted to and search by the name or description or a tag if you want to add tags to it. You could preview it, etc. But let's say I want to change it a little bit or name it. There's a good question I'm going to answer in a second. So let's say I want to change this to otherwise 50, right? So it's pretty much, or actually let's do 0 because that kind of makes more sense anyway. So let's say if one thing I had to do here in the code to make it work is I had to figure out that, that if I'm dividing amount by balance can't be 0 or nan or it will fail, right? So if customer account balance is 0, if customer account balance is 0, I default or nan, I default to 0 because you can't divide by 0. So I change this to 0. I can run it without adding a version and it would create a new one. But let's say I want to name this, right? For some reason. I want to name this default 0. Or sorry, this should be, yeah, the when, it's on the when, right? Yeah. So if I run this now, it will default to 0% if the denominator is 0. And so if I ran this, and I added, notice again, I added a variant. So if I run this now, you can see, I probably screwed something up. Spark provider, found. So let me get these again. I might have lost my authentication. So let me grab those providers again, just to make sure that that's all good. And then let me see what's going on there. Cool. Well, that's what I get for trying to do a live demo. Let me try something a little different. So now it worked, but the first one failed because of the authentication thing, and I'm gonna change it a little bit just so we can watch it run. Now it's running in the background, so I could go to Featureform, I could go to tasks, and I could find it. And you can see that it actually did work and it's ready, but I wanna show you how it looks like from here. So, oh, maybe I'm screwing up. Okay, well, I'm gonna keep going. So you can also write much more complicated transformations. For example, in this case, I'm doing a windowed average of the last 30 transactions. And in this situation, I yeah, you can see I just do this thing. I run it. When I ran it, it finished as ready. I could go find this as well, and I could see the data. There's a question someone asked, which is, how does this compare to something like Airbyte? And it's a really good question. Like, how does Featureform compare? So, like, I'm going to generalize to how would Featureform compare to a data orchestrator? There's many of them. Like Airflow, arguably, is probably one of the most popular ones. And the answer is kind of what comes next, which is Featureform allows you to define features, labels, and training sets. When you do so, you can specify the inference store, like Redis, and it will build this transformation, build the features, and then it will store the stuff in inference store. You could also build streaming features. So you could build features that are based off of streams as well as streaming transformations. You could build triggers so that the feature is updated every time there's a new training job. The big difference between Featureform and a more traditional data orchestrator is Featureform is built entirely for machine learning. So we have a ton of abstractions, a lot of automation, and even in the dashboard, a lot of UI focus around analysis, ML, models, serving, which you would not get in something like Airflow, for example. So that's the key difference. The key difference is, and actually, it's not that it's like you need one or the other. A lot of our users and customers will use one of the many data orchestrators and Featureform. How that works is the data eng team, the more traditional data eng, works in like Airflow. And then where the data scientist will typically grab some files or grab something from that gets generated, and they'll build their features off of those. And so that piece is done in Featureform. So they kind of are complementary, but Featureform is only for the feature pipelines. And then a data infra or the data orchestrators are for the more traditional data pipelines. Great question. So here you can see that I've built these features, built a label, I built a training set. And all those, again, are very easily to view in Featureform. So you could see it's called fraud training. You could see that it's ready. I haven't run in a bit, so you don't see any metrics, but you could see metrics otherwise. You see any features that exist or the features that it uses and the label that it uses. So we could look at the label. We could see the source of that label. It comes directly from the primary in this case. And yeah. So the next bit, and this also kind of answers the next question, which is where does Featureform live in ML lifecycle? So one thing that you do with features, which is unique from like a data set, is you use it for training and inference. So Featureform allows you, once you've defined your training sets and features, to do things like call client.trainingset.dataframe. This will actually generate a data frame off of, or it will turn your training set into a data frame that I can use to train. So you can see I've done that. It grabbed the million rows or whatever, and I work off of that. Now, from here on, not from here on, but this specific next two steps are entirely SageMaker. So here I'm kind of taking this data frame and I'm putting it in the mode that SageMaker wants. SageMaker specifically wants you to put your data frames into S3 again. So I do that here. I create my training data frames. And then I define, I'm going to do XGBoost. I define my hyperparameters. And I run a training job. And a training job, again, you just specify in SageMaker estimator, you specify the instance count, the type, hyperparameters, everything else you need in the training data set to fit on. Now, I showed this earlier, but you could see here that I already ran this training job before. It completed, took 2 minutes. I ran it like not very long ago. And yeah, yeah, you can see all that stuff with the training job. Now, going back to our platform, you can see I've now done stage 1 and 2, or the first column and the second column. The first column was building my features, building my training sets, and then serving them. My second column was building a model, training a model, and then keeping track of those. Now, the third and final column that we're going to do for this webinar specifically is we're going to have to deploy this model and then actually serve it as if it was production. Yeah, let's jump into that. So you can see here what I'm going to do, and I've already done it, so I'm going to run it, but I'll show you it. I deployed a SageMaker instance called, or it doesn't really matter what the name is, but I created an endpoint in that I've kind of put my features into, or my model into. So you can see if I go back to SageMaker that if I go to models, I can see the model that I created earlier. So this model was outputted from the training job. So the training job created an artifact, and the artifact was that model. And so, and you can see it somewhere. It doesn't matter. The point is they created this model, and you could look at the model itself if you wanted to. You could see where it is. This is where, and you can see the training job I trained it as well, right? Now I deploy this model onto an endpoint, and you can see I deployed this endpoint like 10 minutes before the webinar. It's running right now. I last updated it then when I last ran it. And then if I look at this endpoint, you could see that, yeah, just like just some of the basic stuff about it. Now, there's no GPU on it. If there was a GPU, you could see that. You can see but earlier I ran prediction, which I'm going to do again right now. So the final thing I do is I grab my features, I specify parameter, transaction amount. I specify for which user I want it for. Now, this code would not be in this notebook. Typically, this code would be in your application server somewhere. This would be the call that actually gets your features and then runs a prediction. I get my predictor, which is that thing I just built, the thing I deployed. I predict on the features that I retrieved from Featureform. I print a raw prediction, and then I print my final prediction. So I'll see if this works again. So yeah, you can see here that it predicted true, that this is a fraudulent transaction for this user. So this is kind of the final bit. If I was to go back to my instance, you could see if I refresh, I might just catch it, but I'm gonna have to refresh. It's gonna refresh. You'll be able to see maybe in a moment that there was another invocation. I think it's going to take a second to get here. But yeah, you can see that this is all kind of working together. So that's how Featureform would work together with SageMaker, both for training and for inference. The inference serving is something that's very unique to Featureform. So to the question of how is this compared to like Airbyte, Airbyte doesn't have training sets. It doesn't have feature serving. The other thing I did here, which I didn't really get into too deep, is I also defined a on-demand feature. An on-demand feature, I don't know why I import this, but an on-demand feature is a feature. It's like pretty much like a stored function. So this on-demand %, if I go into Featureform, I should be able to click on-demand %. And you would be able to see on-demand %. You can see how it's defined. And Yeah, this is like almost like a Python function that gets run at the time of the request. So when I call this feature, it's actually running this function. And the function itself is actually stored in Featureform, which is, again, a unique thing to Featureform. So this is how everything comes together. This is how we go from to building. So how we went from building our data, defining it, having Featureform build our training set and features, and then using those features to then train our model and do model serving. Now, the final piece, which we don't go into in this talk, but we will in a future webinar, is the evaluation piece. What you'd want there is to keep track of the features that went in and the predictions that were made so that you can kind of see how it's performing in production and perhaps catch anything that misbehaved. There's a question about lineage, which is starts of a data frame continues to track it across evolution. So I'm going to show you something. Oops. I'm going to show you something a little different. Actually, wasn't planning to show it, but it will actually, it's not that hard to do and it will be kind of cool. So when I serve this feature, the other thing I can do is specify a model string. So I can call this SageMaker webinar. If I run this again, I specified this model, SageMaker webinar. If I go into Featureform and I click model, I can see that model that was just created. I can see what features I served to that model. I didn't use it when I created the training set, but if I did, I would be able to see which training set I trained this model on. And what that means is, and this works more seamlessly with MLflow, but what it means is I can, from the model, I can say, cool, I train or I serve these features to this model. I have average transactions. What is average transactions? Well, the source of it, these are the columns, but the source of it is Windows Ads. What is that? Well, I can see how this was built. I can see the user, which is me, who created it. I can see it's run on Spark. I can get the description of it. I can see different versions of this data set. And then, yeah, I could see training sets and features. I can preview that data. I can continue to go down in the lineage. Like I can keep going and say, okay, well, this came from here. Was this? And I can really kind of understand the data all the way from the model down to the raw data. In this case, the raw data is this CSV and S3. So yeah, so that's building a very simple MLOps platform on AWS using SageMaker and Featureform. So SageMaker obviously is very easy to use. It's on AWS. You can just start using it, assuming that you have access to it and you're willing to pay. Obviously, it has some costs. Featureform is open source. You can use it tomorrow. You can use it now. If you wanted to, you can actually get the open source repo. We also have a Docker container. You can just run Featureform locally. We have a quick start, which is probably the easiest way to start, which I would recommend. So you can take a look at that as well. Otherwise, yeah, if there's any questions, feel free to ask. Yeah, if there's any. And then, Marie, is there any questions on LinkedIn or Twitter?
Not on LinkedIn or Twitter, no.
Awesome. Well, give it another second. If anyone has any last questions, feel free to throw them in the Q&A. And then I'll hand it to you, Marie, to do kind of what happens from here. And then, yeah, if there's any questions that come in, I'll answer them after Marie's done.
Thank you, Simba. Yeah, as Simba mentioned, after this webinar, I'll send you guys a little follow-up email. It'll have the link to the recording of this webinar, so you can look back and review things. Also, we'll give you links to our Slack community and our docs. So if you're kind of new to Featureform or using Featureform, or you just want to connect with other people in the MLOps industry, you'll be able to use those links as well. Nope.
Awesome.
Looks like we do have one question.
Oh, so there's a couple questions that just came in. Can you answer? You have extended Featureform pipeline deployment evaluation too. Yeah, we have. So Featureform, well, let me be clear. Featureform only does data. So anything regarded to data, is what Featureform does. So it makes pipelines that you can define and deploy for serving features, for training, production, etc. Featureform purposely does not do model serving, model deployment, or model evaluation. That's by design. There are many great tools that do that. And rather than trying to use Featureform for everything, we think it's a better idea to be very good at one thing, which is the data piece. And for many companies, that's one of the hardest parts of ML, one of their biggest pain points. The second question is where is the documentation? So like where did the definitions get stored? Good question. So Featureform, when it's deployed, is on the open source. It's just in Kubernetes. The Kubernetes is backed by an etcd cluster, which is like a database, and all of the documentation gets stored there. It's encrypted at rest. Enterprise Featureform, we have an enterprise solution. The enterprise solution has way more functionality around security and compliance. The open source is, safe to use. It's just not really meant for like a multi-user, highly regulated environment. That's why we have Featureform Enterprise. So if that's something of interest, obviously feel free to reach out. But yeah, the open source stores everything in etcd, which is encrypted at rest. Yeah, we do track feature versioning, and we have a link to model versioning. So the feature versioning, I kind of showed a little bit of it, but if I look at a feature like, I don't know, like this one, I can see different versions. Now, in this case, I don't have any named ones. Typically, you'd name them once they're like production ready. But every one I build gets a version by default. So I can see every single variant that's ever existed. Like if I grab, I think this one broke, but if I look at this one, you can see it failed. You can see why it failed. And yeah. So everything's version. Same with the models. The model, we don't have it, or I didn't set it up for SageMaker, but for MLflow, you could actually get a link to the MLflow model. So you can kind of see, you can go back and forth between MLflow and Featureform. So we fit nicely with the other tools. And then if it's of relevance to anyone, just based on some of the questions, if you want a kind of more specific demo, especially if you're looking at Featureform Enterprise, feel free to reach out. If you're thinking about open source, please join the community. It's a great place to ask questions and to ask more. Cool. Any last questions before I sign off? Give it just a minute because we've had a lot of them. I want to make sure I get them all. If you do have a question come up afterwards, let's say like 10 minutes from now, you're like, oh man, I wish I asked. You can either email me directly. I'm simba@featureform.com, or you can just join the community, which is a great way to reach me and other people on the team and just other users of Featureform in general. I think we're like 300, 400 people in there. So it's a good place to join and learn more. Awesome. Cool. Well, I think that's all we have for today. Thanks everyone for joining and listening in.
Yeah, thank you guys. Have a great rest of your day.